Hey everyone, Meteorologist Aaron Tuttle here. So, what I've got for you is a little update on the weather. We're going to talk about any changes in the forecast and a current look at radar, kind of get you up to speed there. So, appreciate you joining me. And if you watched last night, last couple of days, I've kind of been letting you know the details of each day's events ahead of time and what you can expect. So, right now, we'll talk about the big picture of things first off. So let's see, let's get you up to speed on this guy here first. So here's a look at the storm cluster we talked about last night, moving through Tulsa this morning. It continues to press slowly to the south. On the leading edge of it is the stronger thunderstorm activity. And that stretches around Fort Smith, Arkansas, back to just south of McAllister, and then Seminole, Norman, and Purcell. Now, along this is going to be some brief flash flooding and some of the heavier amounts of showers and storms. Otherwise, a lot of lightning, all the little plus symbols you see on the screen. A lot of lightning with this, and then once we get back here closer to central Oklahoma, would be the stronger potential area of this cluster. Matter of fact, here in Wayne, this particular storm has a computer algorithm hail detection probability of 100% for severe hail with a size of about 2.5 inches in diameter. So again, that's some near baseball size hail north of Rosedale. This is east of Wayne. Now, what I want you to focus on is we're going to have these pockets of wind and snow the leading edge of this in the southern and southwest as it continues to move south and west. Now, what you want to watch for, you see this little boundary right here? There's a little boundary right here. That's going to be what triggers these storms, and this boundary is sagging to the southwest and the south. So that's how this activity will continue to progress over time for this afternoon. We talked about that last night. If I put this in motion for you, you can see how just in the last few frames, these showers and storms from the north to the south and moving out of the greater Oklahoma City metro area. All right, so that's another key point to make. Let's get a closer view of this particular radar shot. You can actually see there's two boundaries in play. These are outflow boundaries. There was one here that was stalled across the southern part of the metro. And here's this new one from the north and west. And this new one is heading south and west, collide with this southern one. And as it does, bam, bam, bam. So it starts to trigger new storms. It's like an extra kick of lift in the atmosphere to kind of squeeze out that moisture in the form of some storms. So that's what's happening right now. That's enough to break the cap that is in place. Luckily for us, the wind shear is still fairly weak, which we talked about, but it still have directional shear with it. So the probability of a tornado is low with this event. It's not zero, but it's low, just like all these other events have been, and confined specifically to these boundary interactions. In other words, at the initial stage of storm development, you can get a brief, very quick tornado. The reason why it can't last too long is that once it develops on top of this boundary, the flow carries it to the east. The storm does. So once that storm leaves the boundary, it leaves that enhanced vorticity and enhanced vertical shear along with it. And as it pulls away, it can't produce a tornado at that point because it's getting into an environment that does not have that. Again, this is a very key element here. Only get a tornado if you're going to be along this boundary, and it's not oriented to where a storm can last and really linger on the boundary. They get pulled off. So that's good news. All that's good news, which means if we see a tornado today, it should be weak, it should be brief, and the probability is pretty low. But that we'll still watch for that potential. But the big potential for today that we're going to talk about is the wind and hail. All right, so that's the big picture as far as the radar is concerned right now. And then you can tell we are in the moderate risk of severe storms. Actually, excuse me, enhanced, not quite moderate, from south central Oklahoma, southwest on down to Texas. Tornado threat, they put it in just a little hash shading in the area that we're focused on right now for the reasons I told you before. Also, a good chunk of the wind is a potential there, and then also the hail as well. So those are the things to note. So kind of like these other storm systems, we're just kind of talking about a wind and hail event. They did put out a mesoscale discussion, which indicates the southern third of Oklahoma will be seeing a severe thunderstorm watch here shortly. Notice I said severe thunderstorm watch and not tornado watch. Big difference between the two. A warning for the watch is much better than what you'd get for a tornado. All right, now here's a look at the specific outlooks from the local weather service here in Norman. It does indicate some flooding potential. Flash flood risk is slight with a brief flash flooding, some of those heavier showers and storms. Also talks about here in the orange shading, more focused here in southern Oklahoma. And we're going to kind of clip the southwestern part off of Altus and keep it more kind of banked between the 44 and 35 corridor, which we talked about last night, because I'll show you the conditions here in a minute. And then that includes the tornado potential. The tornado potential should be kind of confined in this area here, all right, where I've got the cursor. So let me just do this. The best tornado potential at all, and it's low, is probably going to be something like this area. That's it. South central Oklahoma, that little sweet spot, and it's low. All right, that's good news. Very, very low, as a matter of fact. Okay, and then timing, of course, we already got storms here now, and they'll continue to develop down across Oklahoma. Now, here's a look at the cloud cover structure. That shows that boundary lighting off the showers and storms here across central Oklahoma, and they kind of continue to back build from the east to the west along this boundary. There's a Q field going up with the instability involved. But look down here in southwest. You see this clearing area here? That means southwest Oklahoma. In this area, you're storm free because this is in this pocket, so you can't get storms in dry air. But this is the leading edge of kind of a developing pseudo dry line.
Static?
Yeah. It's a lot of air kind of congealing in this region, converging, and that's what's going to produce some new storm development, and that'll move east. Let's see. All right, so here is a look at the Oklahoma mesonet, and this is the surface features I was talking about associated with that. So you kind of have an area of low pressure that is developing right about here, and then that puts the little dry line development kind of bulge in this area, and then that allows the instability to kind of focus this region here to come in like so. We call this a theta E axis. And you can see the cold pool, or we call it a mini cold front, kind of stretching something like this back into that area. And keep in mind this cold front's kind of moving to the south and west. So that means up here, hey, no problem. You're right. You got the rain-cooled, stable air mass. Here on the kind of dividing line from this area, this is the dividing line. You're still going to have a little leftover storms out behind it. Because the cold front is staggered up. In other words, it starts the surface, but then it's slanted. So you can get storm development along that slant. So it goes back it's going to go back a little bit in altitude, therefore a few miles behind the actual front itself, and we can get good storms. All right, here's a look at how the models have tried to best guess how things will transpire. You can see the focus here across southern Oklahoma and the southwest Oklahoma. They're going to be wrong about the southwest Oklahoma placement. It'll start more to the east, like we talked about. And then here of course, we're already developing now, but you can pretty much discount this northern fringe because we're too far north of that boundary, but it's not too far off. More focus will be down here south of Oklahoma City. All right, we go in time. You can see how these storms kind of continue to evolve across south central Oklahoma and then down across north Texas, and they kind of fizzle out as we head into the late evening hours, which reminds me to tell you, which did I have for that? Let me see. I'm going to show you this guy here. So this again is the overall view of how this storm system doesn't really move a whole lot. It kind of just fizzles on top of it. That's called that decaying squall line that kind of gets going, right? Well, you see the leftover residual here over central Oklahoma. That's the indicative of a mesolow or a MCV, mesoscale complex, which produces an area of low pressure. Well, in that case, you can also get those heat bursts and those pockets of wind we talked about. So if I show you the max wind, we can get that little wake low going. Might be able to get a little bit of that damaging wind in pockets that comes out of that feature. Let's see. Let's go to this guy here. All right. Now, this particular case, the model's shifting most of that focus during the evening hours, to around midnight, so quite a bit earlier in time, but it kind of focuses more over central and southern Oklahoma. So basically this part of the state. Not so much in Tulsa anymore or northern Oklahoma or anything like that. So that's a little bit different with this one is the location of where those gusty winds will be. Plus, it looks like they won't be as strong. I see a lot of 40 to 50 to maybe 60 miles per hour. Don't see anything in here indicating anything greater than that around our area. There are pockets of wind itself that'll produce some wind gusts that could be quite high, especially in western and central Texas. Matter of fact, the scale up here maxes out at 96. So there's some quite good damaging wind potential, just not quite here in central Oklahoma. Southern Oklahoma looks like it might peak close to far down along the Red River. That's where most of the damage reside with this event. All right, so let me see what else I want to show you. So in the process of things, we look for we call a theta E. There's a measure of moisture kind of pulls in, it gets kind of squeezed, like a squeeze plate. And this squeeze plate with a southeast wind is over south central Oklahoma in this shading here. And so I went ahead and added a sounding from that because I want to show you how that can influence the environment in a very small, hyper-local fashion. This is a look at that sounding there. It's got low LCLs, which means very low cloud bases. You can almost reach up and touch those clouds. The wind shear is great as far as directional shear goes, but it's very weak here, 15 knots. So tornadoes don't like to develop in wind shear that's 15 knots in the mid-levels. That's where that boundary comes into play. You're going to need that boundary to overcome this weakness in the wind field. But regardless, you got plenty of cape or instability, which is up around, models will always overestimate, but it's got 5,000 to 6,000, which is ridiculous because we haven't had that much sun, so I won't buy into that completely, but unstable enough to do the deed, keep those storms going. So that's how that can help to trigger a little bit of a weak tornado probability as long as they can get on that boundary. If they can't, then you don't have anything to worry about. Significant hail out of this as well. Algorithms do show up around tennis ball size hail is likely in probably the biggest storms. Okay, so I wanted to show you that as well. Let's see here. This, anything here we really want to talk about? It's no different than we showed you before. Texas will get rocked. Western parts of Texas into North Texas. And let's see, that's about it. Let me take another quick look here at the radar view. Here over central Oklahoma, you can see this boundary moving in from north to south, colliding with the boundary out here, now pushing out toward Chickasha. This is where you get your new development. But like I mentioned before, you see how these storms will develop on top of the boundary, and then they'll blow off the boundary. What you have to worry about is a storm that goes up so fast, so hard, so strong with the updraft that it pulls in the boundary very quickly before it has a chance to blow off the boundary, like this guy here. And then you can get a brief weak tornado. It's not hard. It's not going to be easy to do. It's going to be very hard to do, but it's not impossible. So if this boundary were to slow down any, that opens up that door for much better. Well, it still has a lot of momentum with it. So between now and then, this boundary's going to have to slow down quite a bit. So if I were to try to forecast the time in which this boundary should slow down, it's going to be very hard to do. But we can take a pretty good guess here. That's going to be probably from a line from Apache to north of Duncan to, say, Murray County around Sulphur. So by the time the boundary gets in a position something like this, it should move much slower. So that's where your better opportunity of seeing anything that might try to become tornadic in this area, and then from that point southward to the Red River as that boundary continues to sag southward and becomes more east to west aligned. So remember, the storms, if you've got an east to west align and a storm develops on the boundary, but the flow is to move the storm east, it can ride the boundary. Hence, your tornado probability increases. If you have this northwest-southwest boundary and a storm fires here, it blows off the boundary. You don't get a chance to produce a tornado. So as this boundary continues to sag to the south and west, it depends on how the orientation goes, but you'll have a little bit better east-west orientation in southern Oklahoma than you will where it is currently. So the better likelihood of seeing a freak tornado event would be down here, like I said, from Lawton to Sulphur and point south to the Red River as that boundary progresses southward. And then any interaction that we might have with this boundary and any storms that develop out here around Lawton. So that will be the secondary hotspot. So we could have another region here where that boundary interacts, comes into this location. You already have storms developing, interact with the boundary, or the updraft, tornado. So this would be the area, like I mentioned, I think favorable for tornadoes this afternoon should they occur. All right. That's what I got for you. That's the lowdown. That's the breakdown. That's exactly pinpoint as best I can using all of the meteorological knowledge and tools that I have at my disposal, and hope that was helpful. All right, well, you guys enjoy the rest of your afternoon. Stay safe down there in southern Oklahoma. You know the drill, hail and wind. Stay away from the windows. Comes to a tornado, just seek shelter in the lowest part of your building or home establishment, away from all outside walls and windows, and do not go out there and take a bunch of pictures and video until it rolls right on top of you. I know we like to do that here in the state. I highly caution against that, especially if it's knocking on your door. If it's way out in the field, not coming towards you, knock yourself out. But when it's coming towards you, or it's really close, I wouldn't do that. All right. Anyway, that's my 2 cents. You guys have a great afternoon. Thanks again for watching, sharing, liking the video, all that kind of stuff. I appreciate your comments on Twitter, YouTube, and Facebook. And when you guys give me shout outs and recognize there's a difference between a forecast and storm coverage that I provide versus what you see on the big TV stations, I love seeing those comments, only because that aggravates them. It's a very competitive market, and they don't like me peeing on their tree. And I've been peeing on their tree for the last couple of years, and they don't like it. But it's good because it means there's an alternative you guys are turning to, and they're taking note of it. And maybe, just maybe, by doing this, they'll calm down. Maybe. We can always hope. All right, you guys be great. We'll talk again later. All right, bye-bye.